India stands at a pivotal crossroads in its building energy landscape. With the fastest growing building energy demand globally according to the International Energy Agency, the nation's approach to building energy efficiency represents one of the most significant opportunities for sustainable development and climate action. Hello and welcome again. This is your host Harshit Simha once again with an interesting topic on Buildings Energy Efficiency Program in India, Part 1. This comprehensive overview examines India's holistic approach to building energy efficiency, from stringent building codes and innovative residential programs to market-based incentives and rating systems, and evaluates their collective impact on India's energy future. Let us now explore the topic in detail. Slide 2. Why energy efficiency in building matters. Buildings account for nearly 33% of India's total energy consumption, making them a critical sector for targeted efficiency measures. With rapid urbanization, almost 70% of the buildings that will exist by 2030 are yet to be constructed. This presents both a challenge and an unprecedented opportunity to embed energy-efficient principles into new infrastructure from the ground up. Improving efficiency in the building sector could deliver energy savings of up to 50% by 2030 compared to business-as-usual scenarios. Such interventions generate multiple benefits, including reduced carbon emissions, significant financial savings, and enhanced energy security. Energy efficiency in buildings is particularly impactful given their complex consumption patterns, spanning cooling, heating, appliances, and lighting, with commercial and residential buildings alone accounting for 40 to 45% of the total electricity used. By prioritizing efficient design, advanced technologies, and sustainable practices, India can not only reduce its energy intensity but also enable healthier, cost-effective, and future-ready living environments. Buildings thus emerge as a cornerstone for achieving climate goals, optimizing resource use, and ensuring sustainable urban development. Energy efficiency in this sector is not just a necessity but a transformative pathway toward resilient and sustainable growth. Slide 3. Key drivers and challenges. The transition toward energy-efficient buildings in India is shaped by both strong drivers and significant challenges. A major driver is India's global commitment under the Paris Agreement, which necessitates substantial emission reductions across all sectors, including buildings. Energy-efficient buildings directly contribute to the nation's nationally determined contributions, NDCs, making them a critical pillar of India's climate action agenda. From an economic perspective, energy efficiency presents compelling advantages. With rising energy costs and peak demand burdens, buildings are central to curbing consumption and reducing national grid stress. Energy-efficient technologies not only reduce operational costs for building owners but also mitigate risks linked to volatile energy prices. These benefits create a strong economic rationale for mainstreaming efficiency across India's growing building stock. Despite these drivers, several challenges persist. Implementation gaps remain a serious barrier, stemming from limited technical capacity, lack of awareness, and market hesitancy. Many stakeholders, especially in the real estate and construction sectors, face difficulties in aligning with efficiency mandates due to financial, regulatory, and operational constraints. Moreover, India's diverse climatic zones, varied economic capabilities, and sharp rural-urban differences further complicate uniform adoption. Bridging these gaps requires targeted strategies that integrate policy support, financing innovation, and capacity building. By addressing these challenges while leveraging strong climate and economic drivers, India can accelerate its transition to energy-efficient buildings, ensuring sustainability, reduced emissions, and improved energy security. The future of urban growth depends on how effectively these opportunities are harnessed. Slide 4. National Building Energy Efficiency Program, BEEP. The National Building Energy Efficiency Program, BEEP, is one of the Government of India's flagship initiatives under the Ministry of Power, aimed at accelerating and coordinating energy efficiency improvements across the building sector. Acting as an umbrella framework, BEEP consolidates various building energy efficiency efforts nationwide to foster a sustainable, energy-resilient future. The program adopts a holistic approach by integrating commercial and residential building standards with innovative mechanisms that drive market transformation. It emphasizes collaboration among ministries, state governments, and technical institutions to overcome barriers in implementation and ensure scalability. Key components of BEEP include the enforcement of the Energy Conservation Building Code, ECBC, promotion of Eco-Niwas Sanhita for residential buildings, adoption of star rating systems, and widespread capacity building initiatives for stakeholders across the value chain. By promoting these measures, BEEP not only supports reduced energy consumption and operational costs but also contributes to lower carbon emissions and enhanced energy security. This integrated framework recognizes that achieving large-scale efficiency gains requires a coordinated effort across multiple stages, from design and construction to operation and maintenance, thereby laying the foundation for sustainable and climate-resilient urban development in India. Slide 5. Evolution of Energy Conservation Building Code, ECBC. The Energy Conservation Building Code, ECBC, introduced in 2007 by the Bureau of Energy Efficiency, (BEE), represents a landmark step in India's efforts to promote energy efficiency in the building sector. Over the years, the code has undergone significant advancements to address changing technologies, urbanization trends, and India's growing energy demand. In 2017, ECBC was revised to incorporate stricter performance standards and cutting-edge technologies, ensuring that buildings consumed less energy while maintaining optimal comfort levels. The most recent major update in 2022 pushed the boundaries further, aligning with India's commitments to sustainable growth and climate action by setting even higher benchmarks for energy efficiency. Drawing on international best practices, particularly ASHRAE standards, ECBC has been tailored to India's diverse climatic conditions, with customized requirements for hot, dry, warm, humid, composite, temperate, and cold regions. This adaptability ensures its relevance across the country, from Rajasthan's arid deserts to the cooler Himalayan regions. The code mandates energy-efficient design practices, including advanced insulation, efficient lighting, and optimized HVAC systems, thus driving a systemic shift in the construction industry. Importantly, ECBC not only addresses environmental concerns by reducing carbon emissions but also contributes to energy security, cost savings, and resilience in the face of climate change. Slide 6. ECBC Adaptability and Scope. The Energy Conservation Building Code, ECBC, has been designed as a comprehensive framework to promote energy efficiency across India's rapidly expanding building sector. Its applicability extends to new commercial buildings with a connected load of 100 kilowatts or contract demand above 120 kVA, which typically consume significant amounts of energy. This includes a wide variety of building types such as large offices, hotels, hospitals, educational institutions, shopping complexes, and IT parks. By targeting these energy-intensive sectors, ECBC seeks to maximize overall energy conservation impact. The scope of ECBC is equally extensive, as it addresses multiple building systems that influence energy consumption. These include envelope design, walls, roofs, windows, lighting systems, heating, ventilation, and air conditioning, HVAC, water heating, and electrical power distribution systems. By setting clear efficiency benchmarks across these systems, ECBC ensures a holistic approach to reducing energy use without compromising functionality or comfort. Implementation of ECBC follows a phased strategy. Initially, adoption is voluntary, encouraging stakeholders to integrate energy-efficient practices. Over time, it transitions into a mandatory requirement for government and commercial buildings, eventually expanding to all qualifying constructions nationwide. This phased model provides flexibility while ensuring progressive compliance across diverse building categories. Although ECBC initially excluded residential buildings, complementary measures such as Eco-Niwas Sanhita have been introduced to extend efficiency principles into the housing sector. Together, these frameworks reinforce India's sustainable development goals, supporting energy security, reducing carbon footprints, and advancing the nation's climate commitments. Slide 7. ECBC, Key Provisions. The Energy Conservation Building Code (ECBC) establishes a robust framework for promoting sustainable construction by mandating energy efficiency measures across critical building components. Its key provisions address building envelopes, HVAC systems, lighting, electrical systems, and compliance mechanisms, thereby ensuring a comprehensive approach to reducing energy consumption. For building envelopes, ECBC prescribes maximum limits for walls, roofs, and fenestrations to minimize thermal load. It includes requirements like solar heat gain coefficient, SHGC, for glazing, window-to-wall ratio, WWR, and visible light transmittance to balance daylighting and energy savings. In terms of HVAC systems, the code sets efficiency standards for chillers, air conditioners, and ventilation systems, ensuring reduced operational costs and optimized performance. It also establishes benchmarks for equipment sizing and energy-efficient controls. Lighting efficiency is another critical provision, with ECBC defining maximum lighting power density, LPD, across building spaces. It promotes the use of energy-efficient lamps and fixtures while mandating automatic controls and daylight integration to minimize wastage. For electrical systems, the code specifies transformer efficiency, power factor requirements, and motor efficiency standards. These provisions enhance the reliability of power distribution while curbing unnecessary losses. Finally, compliance options include three approaches: the prescriptive method, specifying mandatory requirements for each system; the performance method, allowing trade-offs between different building components while achieving overall efficiency targets; and the trade-off method, which offers design flexibility. Slide 8. ECBC 2017 and 2022 Key Improvements. The Energy Conservation Building Code, ECBC, has evolved significantly since its inception in 2007, progressively raising the bar for building energy performance in India. While the ECBC 2007 baseline established minimum energy performance requirements for commercial buildings with a connected load of more than 100 kW, subsequent revisions in 2017 and 2022 expanded both scope and stringency. The ECBC 2017 enhanced introduced three performance levels: ECBC, ECBC Plus, and SuperECBC. These tiers created a pathway for buildings to achieve progressively higher efficiency targets. The 2017 code also incorporated advanced renewable energy integration requirements and more refined envelope and system performance metrics. With its design, ECBC 2017 aimed for energy consumption reductions of 25 to 40% compared to conventional buildings, signaling a major step towards green growth and sustainability. Building upon this, the ECBC 2022 Advance brought further tightened performance benchmarks, ensuring that energy-efficient practices were not just optional but more mainstream. It expanded scope to cover modern building typologies and introduced stricter provisions for envelope designs, HVAC systems, and lighting efficiency. The 2022 update also emphasized providing clear pathways for net zero energy buildings, aligning national policies with global climate commitments. Together, these revisions demonstrate India's proactive approach to sustainable construction. The phased improvements allow stakeholders to adapt gradually, while steadily pushing the market towards higher efficiency standards. ECBC 2017 and 2022 thus represent milestones in bridging energy security, cost effectiveness, and climate change mitigation through transformative building practices. Slide 9. ECBC, Compliance and Flexibility. The Energy Conservation Building Code, ECBC, has been designed with a high degree of compliance flexibility to accommodate diverse building designs, technologies, and project needs. Recognizing that energy-efficient construction cannot follow a single, rigid pathway, ECBC provides multiple approaches to achieve compliance while still ensuring the overall goal of energy savings. One key pathway is the prescriptive method, which involves following specific requirements for each building component such as walls, roofs, windows, and systems. This method is straightforward and easy to adopt, making it particularly suitable for projects seeking compliance through standard measures. The whole building performance method offers greater flexibility by allowing simulation-based modeling of the entire building's energy consumption. This enables designers to explore innovative architectural and technological solutions, as long as the overall energy performance meets or exceeds ECBC standards. The trade-off method further enhances flexibility by permitting balancing across building components. For instance, if one component underperforms, it can be offset by superior performance in another, ensuring the building still meets compliance requirements. To support these pathways, the Bureau of Energy Efficiency (B) has developed robust tools and resources. The Eco-Nirman portal provides an online compliance checking mechanism, streamlining submissions and approvals. Compliance checklists and forms make the evaluation process transparent and accessible. Additionally, user manuals and guidelines are available to help stakeholders implement best practices effectively, while simulation tools support advanced performance modeling. This adaptive framework ensures that ECBC remains practical and achievable across a wide range of building projects. By offering multiple compliance options, ECBC empowers stakeholders to choose the most suitable approach without compromising on energy efficiency. Ultimately, this flexibility bridges the gap between ambitious energy goals and practical implementation, accelerating the transition towards sustainable and efficient building practices in India. Slide 10. ECBC implementation at state level. In India's federal framework, the implementation and enforcement of the Energy Conservation Building Code (ECBC) rest with state governments and urban local bodies (ULBs). While the Bureau of Energy Efficiency (B) develops the code at the national level, this decentralized approach enables adaptation to local climatic conditions and building practices, ensuring flexibility and practicality. As of 2023, 19 states have formally adopted ECBC, making compliance mandatory within their jurisdictions. States such as Telangana, Andhra Pradesh, Karnataka, and Gujarat have been proactive in integrating ECBC into their building bylaws and creating detailed implementation frameworks. The state-level implementation process typically involves several measures: notification of the code through official government gazettes, amendments in building bylaws to incorporate ECBC compliance requirements, integration of ECBC compliance checks into the building approval and sanction process, capacity building and training of municipal staff, architects, engineers, and builders to ensure effective adoption, development of state-specific guidelines and tools for construction practices. Additionally, capacity building initiatives remain crucial, as many ULBs lack technical expertise for effective enforcement. The B, with support from international development agencies, provides training, demonstration projects, and knowledge-sharing platforms to strengthen state-level ECBC adoption, ultimately promoting sustainable and energy-efficient construction practices across India. Slide 11. Barriers to ECBC uptake. The Energy Conservation Building Code (ECBC) is an important policy instrument to promote energy efficiency in buildings, but its widespread adoption faces several barriers. One major barrier is awareness and knowledge gaps among stakeholders such as architects, developers, and regulatory officials. Many of them lack comprehensive understanding of ECBC requirements and the technical know-how to implement them. Complex aspects like building physics and energy simulation remain unfamiliar, especially in Tier 2 and Tier 3 cities, which further limits compliance. Another significant challenge is enforcement. Although many states have officially notified ECBC, the actual enforcement mechanisms remain weak. Municipal bodies often lack dedicated resources and technical staff to ensure compliance. Moreover, the absence of strict penalties or accountability for non-compliance undermines the effectiveness of enforcement. Perceived cost barriers also hinder ECBC adoption. There is a widespread perception that energy-efficient buildings are costlier due to the higher initial investment, despite evidence showing that these costs are marginal, typically 2 to 5%, and are offset by long-term energy savings. Developers and clients often focus more on short-term construction costs rather than long-term financial and environmental benefits. Additionally, technical capacity limitations restrict effective implementation. There is a shortage of professionals trained in energy-efficient design, simulation tools, and building commissioning. Limited technical expertise makes it difficult to design and execute projects that meet ECBC standards, particularly in smaller cities and towns where access to advanced knowledge is constrained. To overcome these barriers, coordinated efforts are required, including raising awareness, strengthening enforcement, building technical capacity, and offering financial incentives to make compliance with ECBC both practical and attractive. Slide 12. ECBC Impact. National Estimates. The Energy Conservation Building Code, ECBC, has the potential to bring significant national-level energy and environmental benefits in India. Studies reveal that ECBC-compliant buildings can reduce energy consumption by 17 to 42% compared to conventional buildings, depending on design and compliance levels, ECBC, ECBC+, or SuperECBC. This makes ECBC a critical tool for promoting energy efficiency in the building sector. If implemented effectively across the country, ECBC could yield cumulative energy savings of up to 300 terawatt-hours by 2030. This translates into reducing the need for approximately 150 power plants of 500 megawatts each, thereby avoiding substantial carbon emissions. Such savings would help India achieve its climate commitments by reducing about 250 million tons of carbon dioxide emissions. Beyond direct energy savings, ECBC also plays a pivotal role in market transformation. It has encouraged the growth of energy-efficient technologies, building materials, and construction practices. The policy framework has created demand for skilled professionals and innovative design solutions, indirectly strengthening India's clean energy ecosystem. Thus, ECBC not only reduces operational costs and environmental impact but also fosters sustainable growth. By influencing construction practices and consumer choices, it is catalyzing a broader shift towards energy-efficient urban development. Slide 13. Case Study, ECBC in Practice. The case of Suzlon One Earth Global Corporate Headquarters, Pune highlights the successful implementation of the Energy Conservation Building Code, ECBC, in conjunction with International Green Building Standards. Recognized as one of India's earliest ECBC-compliant buildings, it demonstrates how ECBC principles can be integrated into modern, sustainable campus designs. The building incorporates several key energy efficiency features. Advanced lighting systems, optimized with natural daylight and efficient controls, reduce lighting energy use by almost 30%. The energy-efficient HVAC system employs radiant cooling and displacement ventilation to maximize comfort while reducing power consumption. Additionally, the campus uses renewable energy systems, including a large solar photovoltaic installation and wind turbines, ensuring that more than 50% of its power demand is met through clean energy sources. In terms of performance outcomes, the building delivers remarkable results. It achieves 30% better energy performance than conventional benchmarks, with annual energy consumption restricted to 25 kilowatt-hours per square meter, far below the norm. The site also generates over 150 kilowatts of on-site renewable energy, setting a benchmark for large-scale corporate sustainability practices. This project further earned LEED Platinum certification from the US Green Building Council, reinforcing its global recognition as a model for sustainable design. The Suzlon One Earth campus clearly showcases how ECBC compliance can align with international certification frameworks, demonstrating a pathway for integrating policy mandates with innovative green building practices. It serves as an inspiring example of how large corporate infrastructure can adopt and benefit from ECBC standards. Slide 14. Residential Building Energy Programs, the Shifts. Traditionally, India's energy efficiency initiatives concentrated on the commercial sector, where large-scale consumption and advanced technologies provided immediate opportunities for savings. However, with rapid urbanization and housing expansion, the residential sector has emerged as the new frontier. Projections indicate that nearly 75% of the built space expected by 2030 will comprise residential stock, driven by massive demand for affordable housing and government-backed schemes. This unprecedented expansion presents both a challenge and an opportunity. Without intervention, energy use in homes could escalate significantly. With well-designed programs, residential growth can be aligned with sustainability. Recognizing this, India's policy framework has broadened to incorporate residential energy efficiency. This shift acknowledges the unique characteristics of residential buildings, different usage patterns and energy consumption profiles compared to commercial buildings, greater diversity in ownership and decision-making structures, higher sensitivity to initial costs, particularly in affordable housing segments, varied typologies ranging from high-rise apartments to individual houses, significant informal construction sector involvement in many regions. Ultimately, residential energy efficiency programs are not only addressing India's rising energy demand but also reshaping urban housing by embedding sustainability. By ensuring affordability, resilience, and comfort, these initiatives position the residential sector as a critical driver of India's sustainable development agenda. Slide 15. Market transformation and finance. The transition towards energy-efficient buildings in India is increasingly being shaped by innovative financing mechanisms and the gradual transformation of the real estate market. Recognizing that high upfront costs remain a key barrier to adoption, financial innovation has emerged as a powerful enabler to scale efficiency measures across the construction sector. Innovative financing instruments are expanding access to sustainable investments. Green bonds, for instance, provide a dedicated channel for funding energy-efficient projects, with India already issuing billions of dollars in sustainable bonds linked to building efficiency and renewable integration. Similarly, Energy Service Company (ESCO) models are reshaping the financing landscape by shifting performance risk to specialized firms that guarantee energy savings, thereby reducing the burden on building owners. Other instruments such as green home loans, offered by banks and housing finance institutions at concessional rates, directly incentivize households to adopt efficiency-enhancing measures. Complementing these, partial risk guarantee funds act as risk-sharing mechanisms to encourage lenders to extend financing for energy efficiency projects. Alongside financing, the real estate sector is undergoing a structural transformation. Energy efficiency is no longer viewed merely as an environmental add-on but as a market differentiator. Developers increasingly recognize that energy-efficient buildings command higher property values, faster sales, and reduced operating costs for occupants. Green-certified projects are now marketed as aspirational investments, appealing to environmentally conscious buyers and institutional investors seeking climate-aligned portfolios. Developers integrating energy-efficient materials, advanced HVAC systems, and passive design strategies not only reduce long-term risks but also enhance resilience against volatile energy prices. Furthermore, the availability of green leasing models, wherein tenants and landlords share the costs and benefits of efficiency improvements, fosters broader collaboration in achieving sustainability outcomes. Crucially, these mechanisms also mitigate financial risk. By aligning economic and environmental objectives, they ensure that efficiency investments are no longer perceived as cost burdens but as value-creating strategies. Over time, the synergy of financing tools, real estate innovation, and policy support is set to embed sustainability into India's housing and commercial sectors, reinforcing energy efficiency as both a financial and developmental imperative. Here we conclude Part 1 of the Buildings Energy Efficiency Program in India. In the upcoming session, we shall delve into Part 2 of this topic. Stay connected with the channel, and until tomorrow, goodbye.